was he was going into the next office. He stood up and moved out from behind his desk. What is the atom mostly made of, he thought. Space. He started walking. What am I mostly made of? Atoms. He quickened his pace almost to a jog now. What is the wall mostly made of? Atoms. All I have to do is merge the spaces. Then General Stubblebine banged his nose hard on the wall of his office. Stubblebine, who commanded 16,000 soldiers, was confounded by his continual failure to walk through the wall. He has no doubt that this ability will one day be a common tool in the military arsenal. Who would screw around with an army that could do that? That's from an article in Playboy, which I was reading the other day. I've every reason to think it's true. I was reading Playboy because I myself had an article in it. Unaided human intuition, schooled in middle world, finds it hard to believe Galileo when he tells us a heavy object and a light object, air friction aside, would hit the ground at the same instant. And that's because in middle world, air friction is always there. If we'd evolved in a vacuum, we would expect them to hit the ground simultaneously. If we were bacteria, constantly buffeted by thermal movements of molecules, it would be different. But we middle worlders are too big to notice Brownian motion. In the same way, our lives are dominated by gravity, but are almost oblivious to the force of surface tension. A small insect would reverse these priorities. Steve Grand, he's the one on the left, Douglas Adams is on the right. Steve Grand, in his book Creation, Life and How to Make It, is positively scathing about our preoccupation with matter itself. We have this tendency to think that only solid, material things are really things at all. Waves of electromagnetic fluctuation in a vacuum seem unreal. Victorians thought the waves had to be waves in some material medium, the ether. But we find real matter comforting only because we've evolved to survive in middle world, where matter is a useful fiction. A whirlpool, for Steve Grand, is a thing with just as much reality as a rock. In a desert plain in Tanzania, in the shadow of the volcano Oldonyo Lengai, there's a dune made of volcanic ash. The beautiful thing is that it moves bodily. It's what's technically known as a barkhan, and the entire dune walks across the desert in a westerly direction at a speed of about 17 meters per year. It retains its crescent shape and moves in the direction of the horns. What happens is that the wind blows the sand up the shallow slope on the other side, and then as each sand grain hits the top of the ridge, it cascades down on the inside of the crescent, and so the whole horn-shaped dune moves. Steve Grand points out that you and I are ourselves more like a wave than a permanent thing. He invites us, the reader, to think of an experience from your childhood, something you remember clearly, something you can see, feel, maybe even smell, as if you were really there. After all, you really were there at the time, weren't you? How else would you remember it? But here is the bombshell. You weren't there. Not a single atom that is in your body today was there when that event took place. Matter flows from place to place and momentarily comes together to be you. Whatever you are, therefore, you are not the stuff of which you are made. If that doesn't make the hair stand up on the back of your neck, read it again until it does, because it is important. So really isn't a word that we should use with simple confidence. If a neutrino had a brain which had evolved in neutrino-sized ancestors, it would say that rocks really do consist of empty space. We have brains that evolved in medium-sized ancestors which couldn't walk through rocks. Really, for an animal, is whatever its brain needs it to be in order to assist its survival. And because different species live in different worlds, there will be a discomforting variety of reallys. What we see of the real world is not the unvarnished world, but a model of the world, regulated and adjusted by sense data, but constructed so it's useful for dealing with the real world. The nature of the model depends on the kind of animal we are. A flying animal needs a different kind of model from a walking, climbing, or swimming animal. A monkey's brain must have software capable of simulating a three-dimensional world of branches and trunks. A mole's software for constructing models of its world will be customized for underground use. A water strider's brain doesn't need 3D software at all, since it lives on the surface of the pond in an Edwin Abbott flatland. I've speculated that bats may see colour with their ears. The world model that a bat needs in order to navigate through 3 dimensions catching insects must be pretty similar to the world model that any flying bird, a day-flying bird like a swallow, needs to perform the same kind of tasks. The fact that the bat uses echoes in pitch darkness to input the current variables to its model, while the swallow uses light, is incidental. Bats, I've even suggested, use perceived hues such as red and blue as labels, internal labels, for some useful aspect of echoes, perhaps the acoustic texture of surfaces, furry or smooth and so on. In the same way as swallows, or indeed we, use those perceived hues, redness and blueness, etc., to label long and short wavelengths of light. There's nothing inherent about red that makes it long wavelength. And the point is that the nature of the model is governed by how it is to be used, rather than by the sensory modality involved. J.B.S. Haldane himself had something to say about animals whose world is dominated by smell. Dogs can distinguish 2 very similar fatty acids, extremely diluted, caprylic acid and caproic acid. And the only difference you see is that one has an extra pair of carbon atoms in the chain. Haldane guesses that a dog would probably be able to place the acids in the order of their molecular weights by their smells, just as a man could place a number of piano wires in the order of their lengths by means of their notes. Now there's another fatty acid, capric acid, which is just like the other 2, except that it has 2 more carbon